Hey guys, it's Sam for Digital Meat, and in this Cinema 4D tutorial we are going to be looking at volume modelling. Volume building is new to Cinema 4D R20, so if you have a version lower than this, then I'm afraid you're going to be out of luck. So with that in mind, let's begin. If we have a look at the menu across the top here, we now have a new addition. This is the volume menu. In this menu we have a few items, but I'm going to start with the volume builder. So now we have this volume builder object in our object manager. Like most generators in Cinema 4D, the volume builder works with a parent-child hierarchy, so we need to feed something into this object as a child. So I'm just going to create a torus, and we're going to put that inside our volume builder. As you can see, our torus object has been voxelated. It's at this point I want to explain what a voxel is and explain what is actually happening here. A voxel can be thought of as a three-dimensional pixel. Just like a pixel, a voxel's coordinates are not explicitly defined, but rather inferred from its position relative to other voxels within a grid. This is unlike polygon objects, which are defined by explicit vertex coordinates. I don't want to get too bogged down in the technical details of voxel grids, but I can actually demonstrate what is going on with the volume builder with a cloner. So I'm just going to turn off this volume builder for a minute, and I'm going to create a Mograph cloner. I'm also going to create a cube, and let's say that this is 20 by 20 by 20. Let's put our cube in our cloner, inside it, and in the cloner I'm going to change it to a grid array, and I think 10 should do it. Yeah, 10, 10, 10. Okay, and let's change this to per step, and then I can actually change this to 15 and it will just add the blocks on. There we go, lovely. So this is representing our voxel grid, if you like, and it will be another polygon object or another shape that will define the values of our voxels. So if I create a sphere, that's actually sat inside of our voxel grid. So let's grab that again. So you can see it's there, and it's kind of sat inside of it. And then I'm going to select the cloner, go to Mograph, Effector, Volume, and then it's asking for a volume object, and that's our sphere. So I'm going to pop that in there. And in this, I'm just going to go to the parameters and turn the scale off and turn the visibility on. And I can also hide our sphere now. So that's basically what's happening in our volume builder. Our sphere is defining a value for the voxels that is that this shape encompasses. So it's basically saying, oh yeah, there's a value of 1. This voxel is on. And if I grab the sphere and enlarge it, it encompasses more of the voxels, and so the value of those voxels changes. So yeah, okay, so that's just a quick explanation of that. Let's get rid of all of that stuff. It's important to note that what I've just shown you with the cloner is just a visual aid. What the volume builder is actually doing in comparison is far, far more efficient. So let's move on to the volume builder. Let's turn these back on. So if we zoom into our voxelized torus and move around a little bit, you'll see that it appears that these so-called voxels, well, they are voxels, aren't displayed as three-dimensional objects. They actually look like small planes that are always facing the camera. Now, I highly suspect this is to keep Cinema 4D's viewport optimized and moving quickly. And I thought it was worth mentioning, as some of you may be wondering why these voxels aren't being represented as a 3D object. Okay, so let's select our volume builder. In the object tab, our first option is the volume type. We have the choice of sign distance field or fog. The help documentation actually has some great imagery that depicts the difference between these two options. So let's take a look. Right click on the volume type, go to show help, and there we go. This is a really good example of the sign distance field. So the sign distance field volume type is typically used for modeling. It works by placing voxels within a range on the exterior side of polygons shown here. So these are front-facing normals, and it also does the same thing for the interior range here, which is the back-facing normals. So it kind of puts voxels on either side of the polygons. The fog volume type differs in the fact that it entirely fills a polygon object with voxels. This method is typically suited for rendering fluids, fire and smoke, that kind of thing. So since we're going to be modelling, we will stick to the signed distance field method. I just wanted to show you the difference between those two. Okay, so next on our list we've got the voxel size. This can be thought of as resolution really. So if I make the voxel size bigger, so let's put this up to 20, it actually makes the resolution lower. And if I put this lower, if I make the voxel size smaller, it actually increases our resolution. So just think of this as a resolution setting. Underneath our voxel size, we have the objects list. This list contains all the objects that are being voxelated by the volume builder. As we saw earlier, by making our torus a child of the volume builder, it has been automatically added or included in this list. And if we look at the input type here, we can say it says child. This is not the only way that an object can be included in this list. So if I pull the torus out and select the volume builder, there's nothing in there now. We can actually grab this torus and just drag it in. So now this torus is included in this list and is being voxelated, but you can see now the input type isn't child anymore, it's actually link. An upshot of this is that the volume builder and the torus are now independent of each other. So if I move the volume builder, we can still see that it references this, but it can be moved independently. So I'm just going to undo that, and I'm going to change our input type for this back to child to keep things nice and simple. Okay, so we're back to the way we had it. Okay, the real power of the volume builder is realised when we start adding multiple objects, so let's do that. I'm going to create a cube and I'm going to change its size. Let's go for 150, I think. Yeah, that should do us. And then what I'm going to do is make this editable, go into polygon mode and press Ctrl A, so I select all the faces. Then I'm going to unselect the top and the bottom, and then I'm going to go into our extrude tool. So right click, extrude, and then extrude this out like this, and then I'm going to click the preserve groups. I'm going to uncheck that so we get this kind of thing. In fact, I might even extrude a little bit more than that. Here we go. Cool. Okay, then let's go back into object mode and scale. I'm just going to scale this down a little bit, and let's pull this up. Okay, so we've got this kind of thing, it's intersecting there. And now what I'm going to do is add this to our volume builder. So like before, I'm going to grab our cube and drag it in. And you can see that the cube object is now being voxelized. So I'm going to rename this cross, because that's what it is now, it's not a cube. And let's have a look in our volume builder. So now you can see this cross has been added into our list, with the exception, the way it differs from the torus is it, under mode, it's now got this drop down menu that says union, subtract and intersect. So you may be thinking, well, why has this got that and the torus hasn't? The best way I can explain this is to imagine these objects in this list here as layers, kind of like in Photoshop. So they stack on top of each other. So the cross being on top of the torus means that you could kind of see this mode drop down as like a blending mode in Photoshop. So obviously the torus is the base layer, so it's got nothing to blend with, if you like, although this isn't a blend mode. And if I swap these over, you'll find that the cross wouldn't have that option anymore. So it's because the torus is the base layer. So let's get the torus back as a base layer, and the cross is now on top of the stack. It's kind of like when you stack materials up in Cinema 4D, you'll have the material tag furthest to the left being, at the bottom of the stack. And as we move right, those materials are stacked up on top of each other. It's kind of like that. So now we've got our cross on top of our torus. Let's have a look at what these options actually mean. We've got union here. So this is kind of like how the Boolean functions. Now we've got a union, and it'll probably be better to see this if I actually make this a mesh. In the volume builder, when you put objects in there, they get voxelized, but voxels aren't renderable. So if I click the render button now, they won't be in the render. So we've got to now convert these back to a mesh. So if we go to the volume menu, we've got this volume mesher. And just like the parent-child relationship with these objects in the builder, we can grab the builder and put them in the mesher. And now our voxels become a mesh. And if I press NB, you can see the topology of this mesh. So it's pretty good. I'm going to press NA again, just so we're back to where we were. And then go back to the volume builder. Okay, so at the moment, this cross is set to union. And as you can see, it's actually created a union between these two objects. And if I look at the mesh again, you can see that, where these two things connect. Also to mention about the mesh, you can see that it's a regular grid on this cross and not so regular here on our torus. And that is because it's using the voxels as a way to determine the mesh. But even though this looks very irregular here, if we zoom in, you can see that each one of these polygons is actually a quad. So we've got a diamond polygon here, and it's a quad. It's got 4 sides, same here. So even though it may look irregular, by putting the volume builder in the mesher, it only creates quad polygons, which is absolutely fantastic, because that means that this mesh would be suitable for deformation and that kind of thing. Okay, so back to our builder, and I'm going to change our view back to our shaded mode. We can see that there's a union between these two objects. Now, we've also got the option of subtract. So if I subtract, it's now subtracting this cross from this torus. So you can use it to cut chunks out of objects. Now, this is amazing, really, because we all know that the Boolean object isn't the best at creating meshes that are great, to be honest. And obviously the mesh for this is all quads. That's fantastic. The other thing on our list, we've got intersect again, like the Boolean tool. So where this sort of cross intersects this torus, it will actually get rid of everything else and keep the intersection. So we'll have a look at that, and you can see that it's kind of created these wedges here. I'm going to switch this back to subtraction, or subtract even. So we've got these, we're using our cross, almost like a mask really, to cut out of this object here. Now, if we look at this, you'll notice that it looks quite faceted. It's almost like you can see the facets of the sort of underlying polygons that are generating these the voxels. And there's something we can do about that. Well, there's several things we can do about that. Like I said, this voxel size here is kind of like resolution. So if I actually lower this to maybe something like 2.5 or something like that, we get a lot more resolution, and you can actually see the facets now of this polygon object. So what are we going to do about that? Well, we've got some filter layers. In fact, if you go up to the volume menu, you can see that we've got this smooth filter and reshape filter. So let's have a look at these two. Let's start with the smooth filter. So with my cross selected, I'll select my smooth filter, and the smooth layer gets put on top of what's selected. And as you can see in the viewport, it has actually smoothed out this, but we've, which is what we wanted for this torus, but we've kind of lost some definition here. So what can we do about that? Well, we can actually use folders to segregate the smooth layer and objects. So I'm going to deal with the torus first. Like I said, it's kind of like layers, kind of like a stack. So this smooth layer is on top and is smoothing everything underneath it. If I move this smooth layer down in between the cross and the torus, now this smooth layer is only smoothing the torus because that's what's underneath it. So let's have a look at the smooth layer itself and its options. So here we've got a strength, which is 100%. And if I slide this down, you can see that it's getting less smooth. All the way down to 0 is like the smooth layer isn't there, and if I go up you can see it getting smoothed now. We've also got the filter types as well. So we've got a Gaussian filter type, we've got mean, median, and we've got a mean curvature. So all of these are kind of algorithms that do different things. For my torus, I'm actually going to keep it on Gaussian. We've got a voxel distance here, so the range in which it affects. If I put this up, you can see, well, I've gone too far there. You can actually start seeing the voxels, the underlying voxels. And if I go back to 2, it's a lot better. And if I go down, obviously it's going to be, the distance is going to be lower. So I think 2 is going to be okay for now. And then underneath this, we've got iteration. So how many times this smooth filter has been iterated, if you like. So this is the result of 1. And if I crank this up to, say, 3, you can see that it's run the smooth multiple times now. Well, 3 times. So I'm actually quite happy with the quality of the smooth on the torus now. So what about the intersecting cross? It's not being smoothed at all. So if I select the cross and then put a smooth layer on it, we're going to have problems, because this smooth layer that is now top of the stack is not only going to be smoothing the cross, but it's also going to be adding to the smooth layer here and again on the torus. So if I turn this on and off, you can see the result of that. It's just smoothing everything. So how could I get it so this smooth layer is just affecting this cross? Well, I suppose I could move all of this down to the bottom of the stack, but now we've got another problem, that this cross is not being subtracted from the torus because it's below it. So let's just undo that. So they're back where they were. And you can see this little button here. It looks like a folder, and that's because it is. And it says create folder. So let's create a folder, move it to the top of the stack, and now we can use this folder to segregate these 2 things. So let's put our smooth layer in there and our cross layer in there. And now you'll see that the cross has reappeared, and that's because it hasn't got its mode drop down has disappeared, because now it's in a folder. So now we have to go to the folder and say subtract there, and then we're back to where we were. Now we can actually affect this smooth layer, which is only affecting this cross, separate of what's happening outside this folder. So I'm going to choose mean curvature, because I want to maintain these sort of sharp edges, and maybe 2 iterations, see how that goes. And now we've got these sharp edges and a smooth torus. Brilliant. The other thing that we've got here is a reshape layer. I'm actually going to open up a new scene for this. And again, like before, let's create a volume mesher, volume builder. And in the volume builder, I'm just going to create a couple of shapes, really simple shapes. Maybe 2 cubes, that'll do. And let's select both of these cubes and maybe fillet them, maybe get them to be a bit more interesting. And I'm going to drop both of those in our volume builder. As you can see, they've been voxelized, and we'll put the volume builder in our mesher. And there we go, there's our cubes. Great. In the volume builder, what I'm going to do is add a reshape layer, because I just want to show you what this layer does. So now that I put this in, we can select the reshape layer and then see its attributes underneath. Now we've got a strength, just like we did with our smooth, and we've got a filter type. So we've got dilate or erode or close and open. So let's start with dilate and erode. We've got this offset value. So positive numbers actually dilate. So if we move this up, we can see that they dilate, and when they hit each other, they actually merge, which is lovely. And negative numbers erode. So if we were to go back to the beginning, in fact, if we turn this shape layer off, you can see that at the value of 0, it's the same as it being off. And if we go into negative numbers, you can see that these shapes get eroded. And if we keep going down, they keep getting smaller and smaller and smaller. Great, so that's pretty easy to understand. And obviously the iterations, again, how many times that erode or dilate function is iterated. Obviously, iterations of 3, but with an offset of 0 doesn't really mean anything. So if you put 5 in there, and then we change the iterations, we've got 3 there and 1 there. So it just repeats the process, if you like. Okay, the other thing that we've got is close open. So if I switch to this, I don't actually know if it's going to work with these 2 objects, but basically this attempts to close holes in the mesh, basically. So if we ramp this up, yeah, you can see that it's detected there's a gap between our 2 cubes, and it's trying to solve, getting them together, if you like. So as we increase this, it tries to bridge that gap between them. So that's basically what the reshape layer does. And I can now close this window and get back to our other scene. Okay, so now we've got this. Brilliant. What next? Well, it's not just polygon objects or primitives that you can dump in the volume builder. You can pretty much throw anything you like at it. So let's grab a Mograph cloner, and I'm going to create another cube, and I'm going to make this cube, I don't know, let's say 50 by 50 by 50. That looks good to me. And let's make it tall on the Y. Yep, that's good to me. And let's whack this cube in our cloner. And in the cloner, I'm going to go to the Object tab and change it to a radial, and change its radial plane to XZ. And let's change the radius so our objects actually come out there. And let's bring this down to 4. Okay, so now we can actually use this cloner as a mask. So let's dump the cloner in our volume builder. Job's a good one, and by default you can see that it's actually a union. And I'm going to actually change this to a subtract so we can cut some holes out in our object here. It's very good. And yet again, that could probably do with a bit of smoothing or something like that. So let's have a look at this. So that's the smoothing there. And again, I could create a folder. Oh, it's appeared at the bottom. Drag it all the way to the top, put our cloner in it, and then create a smooth in there as well. Change this back to subtract, and you can see that these have been smoothed out a lot more. I'm going to change this smooth layer to maybe a mean curvature to try and retain some of that detail there. And also let's drop this down to maybe a 1.5 so we get a bit sharper detail, and that's looking good. So that's just an example of one of the generators you can lob in there. We've got a cloner in there, and it works just as well as a polygon object. So what else can we do? Splines. You can also do splines. So let's go into our splines and create a circle spline. Let's just leave it like that for now. Let's lob it in our volume builder. And as you can see, it looks like it's been sampled along the spline, and it's created balls at points, at even points around the spline. So let's have a look at the settings for that in the volume builder. So clicking the volume builder, we can select our circle, and we've got some options here. We've got a radius, so obviously that controls how thick it is. So if I put it up to 50, you get this kind of result. So let's put it down to something manageable. 20 is good. I don't know, let's say 10, something like that. Yeah, you can really see that these are sort of samples around there. Now, if you wanted this to be a smooth spline, we can use this density setting here. And it's kind of the density of the samples that are being used around this circle. So if I crank this up by 0.1, you can see that it kind of gets smoothed out. I'm going to put this up to 0.5, and then we get a really nice smooth result. And that's really, really, really good. Let's have a look at the mesh for this. I should imagine it's pretty heavy now. Yep, it is. But it's a very, very clean mesh. So yeah, that's splines. Okay, something else that we could do. We could even use a symmetry object as a kind of mask if we wanted to. So let's create a symmetry object. We'll create a cube, put that inside of our symmetry, and make sure our symmetry is on the XY plane. And then let's resize this cube because it is a little bit big. Let's make it 100. That's fine. And then we can actually move this cube out like this and maybe just have it sort of connected to the edge there. And we could even fillet the edges of this cube. Not that much. Okay, and then we can put this symmetry inside our volume builder. And that too becomes part of the mesh. It's connected beautifully there. So, I mean, if we look at the mesh for this, again, it's quite dense. We could change that by affecting this voxel size here. We could actually put this up to 3 or something like that, and it wouldn't be so dense. But to polygon model this would take a fair bit of time. And by using this method, we can get really, really organic shapes very, very quickly. So, this thing's a lifesaver, really. If you had to iterate something, on the fly, you needed to get it made quickly, you could use objects as masks to cut bits out of other objects, and you could get a result very, very quickly. So I think we're done with this scene file now, and I'm actually going to create a new one. So let's close this, and we'll use this one. Something else that you can do in the volume builder, which I think is absolutely incredible. Let's grab the volume builder, and actually let's go to simulate and get an emitter, because even particles can be used inside the volume builder. Let's grab our emitter and rotate it upwards like this, 90 degrees, that's good. And let's just hit play and see what's going on with these particles. Well, first of all, let's put some more time on our clock. 5 seconds should be good, and let's make our particle lifetime the same, I suppose. And the speed's okay. We could probably make our emitter bigger so these particles are a little bit more spread out. And I think, has that scaled the speed as well? Yeah, it has. So let's slow this down to maybe 200. Okay, great. So we've got these particles coming out of this. Let's put our emitter in our volume builder. And you can see that our particles have been voxelized. So let's have a look in the volume builder. And you can see here, let's bring this down to maybe 5, something like that. So we've got a bit better resolution there. So this emitter is in here now. And if we click on the emitter, you can see the radius is set to 15 centimeters. So if I lowered that, it just means the radius that voxels are created around these particles is now lower. So let's put this back up to 15. The velocity scale, I'm not actually sure what this does. So let's put that up to 5. Okay, let's have a quick look at this. Velocity scale. Larger values will create correspondingly longer tapered volume trails behind each particle. A value of 0 will disable the effect. This is an excellent method for creating self-closing elements such as an open wound or a tunnel, etc. Well, that's very interesting. So maybe not 5, let's put it down to 1 and see what happens. And then go back to the beginning. Okay, so the trails actually follow as well. That is very, very cool. Okay, so maybe I'll leave that at that. But the interesting thing about using particles is we can still use this with other stuff. So if I create a cube, and let's make this flatter and just pull this out. So we've got kind of like a flat plane like this, and then pull it up. So it's like this. What we can now do is drag our cube into our volume builder underneath the emitter, actually, or do we need it over it? Yeah, actually, we want to reorder this. The cube is the base layer. And then what we can say is with the emitter, instead of it being a union, although that could look pretty cool, let's have a look what that looks like. Okay, so they're going up. And they're kind of just merging with it. I wonder what it will look like if we put a smooth layer on top of both of these things. Slow down quite a bit. Now the smooth, it looks like it's disappeared. And it's because this smooth layer has smoothed out these particles too much to the point where voxels have been sort of, disappeared, if you like. So if we go to the smooth layer, I think we can adjust the volume distance, maybe. There we go. So we can affect that volume distance. Let's turn up the voxel size as well, maybe. Or in fact, let's go to the emitter, in the volume builder, and make this velocity scale 0, just so we can keep things nice and quick. Yeah, maybe the voxel size. Yeah, again, by increasing the voxel size, I've actually managed to disappear the particles there. So let's just keep it like that for now. But you can see they're merging in. But something that we could do with this is actually, let's bring this down a little bit to maybe 7. Yeah, that's good. We could actually make this emitter be subtractive. So now when the particles hit this, they're being subtracted from that mesh, and you can get some pretty cool strange effects like this. And if I was to now put this in a volume mesher, this has that's very cool. This actually has a property called the let's click on that, the voxel range threshold. So if we rein this in, you can see what effect that has, and you can see that those blobs now are more prominent. And if we increase it, they probably disappear. So let's just wait for it again. Yes, they have disappeared. So by default, this is set to 50%. It's also important to note that this voxel range is associated with, in the volume builder, the voxel size. You can see there's a little arrow here. So if we drop this down, you can see that we've got the interior voxel range and the exterior. So if we increase this, let's see what effect this has. So by increasing that, it looks like our things are more prominent. So let's increase that even further. But yeah, just to let you know that these are associated with this thing in the volume mesh. It kind of is. This is kind of like a bias, I suppose. So yeah, that's something else that you can do with the volume builder. As far as I've got anyway, I haven't experimented with hair yet, so that could be something to do. But this looks like it could be really, really useful. An incredible tool in Cinema 4D. So that's just scratching the surface for the moment. And obviously, as I work through using the volume builder and the new fields as well, and I think in conjunction, those two things could be absolutely amazing. So that'll probably be my next tutorial, the fields in the new fields in Cinema 4D R20. Okay, guys, thanks for watching. For my viewers on YouTube, please like and subscribe, and don't forget to hit that bell to be notified of new tutorials. You can check out content at digitalmeat.uk, where you can filter my tutorials by category and vote in the poll for upcoming tutorials. You can also follow me on social media, links in the description and the footer of my website. If you'd like to help support Digital Meat, this can be done via Patreon or the support page on the website. But if you want to help Digital Meat keep going and bag yourself some extra in-depth tutorial content, the Prime membership is available for purchase in the store. This will grant you access to the Prime membership area of the website. I also have a second YouTube channel called Beef Doctor, which is a bit of a dumping ground for non-3D content and where I'm streaming games. There's a link in the description and the footer of digitalmeat.uk. I hope to see you guys in the chat. Thanks for watching, guys. Bye.